make sure when teaching ancient Egyptian mathematics that it's taught through a casual, cultural, play-based environment. Ancient Egyptians used fun, child-centered games to teach math concepts. Math was rarely taught in a classroom. It was most commonly taught in a village setting or through rites of passage initiation schools, and it was taught largely culturally. Africans, even until this very day, tend to teach culturally. It's very important that when you teach African math or Egyptian math or Olmec math or even Babylonian math, that it's taught through a cultural lens more so than taught as an academic study. And the reason that that is suggested is because learners do not live in the classroom. But when they enter into the world, their culture surrounds them. There are also valuable lessons in the language of different cultures. Language is very important when it comes to teaching certain concepts to learners, where there are specific algorithms that are embedded in ancient languages that teach learners how to count. Believe it or not, very sophisticated algorithms. And South Africa, for instance, has a very, very profound name for the values of 8 and 9. 8 in South Africa means 10, leave 2 behind, or take away 2. And 9 means 10, leave 1 behind. This house of 10 looks very similar to Nguni houses in Southern Africa. If you go to South African villages, you'll see houses shaped like this, as well as this is often the doorway and window opening for row houses that are in ancient cities throughout the world, as well as ancient granaries and cisterns. Used to have what's called the African arch or the Nubian arch, and it's shaped like this. This shape in the African math system represents a house of 10. This is very helpful when it comes to teaching learners place value, because the symbol conceptually matches the quantity. And learners also find these shapes extremely easy to draw, which means now they can start applying numeracy concepts years before they have the fine motor skills to write traditional international numbers. As you followed along with the lesson, I'm sure you could count on your own and even figure out what these symbols mean. These tally marks represent a quantity of 1. And as you stack or build a quantity, it's very easy to see that they can be counted, and you match the name to the quantity, which is very beneficial if you're counting in multiple languages. I'm going to translate when I get to 8 and 9, how South Africans have this very sophisticated way in which to count that's beneficial to the way that learners would use the African abacus in antiquity. This Mancala board is a category of game boards that have been used throughout Africa for tens of thousands of years, if not hundreds of thousands, which was used to teach numeracy concepts since the beginning of humanity. And the language explains how to use the board. There's also algorithms embedded in the Nigerian language with their counting system. Let's have fun counting. I'm going to do it in English, but we're going to show you how the system can be used in the classroom today. Again, of course, this is the ancient Kemetic number for 1. This is the ancient number for 2, 3, 4, 5, 6, 7, 10, take away 2, 10, take away 1, and then we're going to count 10, 20, 30, 40, 50, and so on. Once you see the pattern, 60 seems to be pretty obvious. 70 seems to be pretty obvious, and so forth. Now, here's the advantage of how to use this counting system in the African abacus. Again, there's one-to-one correspondence. If I see 1 bead here, I place 1 bead. If I see 2 beads here, I place 2 beads, and so on. So the same is true for the board, okay? Now, we're going to get to the tens later, but I want to first introduce this symbol. This symbol that you see here in 10 take away 2 and 10 take away 1 makes it obvious that this symbol is our takeaway symbol. This is a very important symbol because it represents subtraction. Now, if this symbol, a dot, represents 1 or unit, digit, we call them bits, or this tally mark represents a dot or 1, which we call bits, what happens when you combine the two? What happens when you combine a takeaway with a positive bead or a positive quantity? So if these symbols equal addition or to place, and this symbol equals subtraction or to erase, what happens when we put them together? Well, what happens when we put them together is something that's called a zero pair. A zero pair is a negative combined with a positive. Again, a zero pair is a negative, which is an open circle in our system, combined with a positive. And that's what a zero looks like. This is very helpful, as you see here with the ancient Mzansi counting system, where they included the concept of negative integers or negative values in the very counting system. The same is true for other African languages, like I mentioned with the ancient Nigerian languages. Why is that important? Well, let's count. I'm going to show you. It's very important when you count 1, that's a positive value, 2, 3, 4, 5. Okay. Now, what if your next number was, let's add 10, take away 5. Okay. If it was 10 take away 5, then the value would equal, 10 take away, it would equal 5, which was what we see here. We're going to get into that later. What I really want to teach you is the concept first of zero pairs. So now we have 5. Okay. If we have 5 now,